I'm Dr. April Bowman. I'm a research civil engineer for ERDC, and this is the Centrifuge Research Complex, and I am the person that runs it. We spend a lot of time building amazing models that we destroy in 10 minutes to 2 hours to a day. That's the best part. The success comes when the model works, everything mechanically within the model works, because again, that's kind of a crapshoot depending on what we're doing on the centrifuge and how the G-forces are going to miss with that. But then also it's the failure of the model, the things we can see. Not every model's perfect. We've had models that didn't work the way we thought they would. They're still interesting, there's still data to be had, and there's always the fun of the detective work afterwards to figure out why something did or did not work. And sometimes that can lead to other research as well.
This is basically a time machine. It speeds up processes. We scale it down and we can speed up processes, and it's much cheaper this way than trying to do it on a full-scale level. The higher the G that we go up, the faster those processes happen. So when we build something like a levee like that, an overtopping, we can speed that up, and we had 17 days worth of erosion happen in an hour and a half. So when I say time machine, we don't go back in time, but we can go forward quickly.
One of the big areas we're working in now is the flow of water. That's a really tricky problem in the centrifuge, because now you're looking at scaling laws that may or may not line up depending on the pore size of the fluid flowing through the sand. That also scales in theory. And so then by that, then the fluid should scale and the flow should all scale. It's not entirely clear how that works. So that's an area where we're trying to expand into to understand a little better how these scaling laws apply to things like fluid flow, which again, internal erosion is an internal fluid flow problem. Even the overtopping tests that we're doing, a lot of that relies on how the fluid is running over the levee and erosion issues there. So there are areas where gravity is helping us, but then it also makes it absolutely more complex. And it's just understanding those forces and how they're changed by the addition of gravity. And that's the goal here at ERDC. We are fundamentally trying to find out how things work, which includes determining how things fail, so we can engineer against these failure modes. Engineering isn't just delivering some final design or project. To truly be good stewards of our environment and our craft, we need to consider service life, use, constructability, repair potential, etc. And here at ERDC, we're one team on the forefront of that research.